Welcome, friends. In this discussion, I'm going to be covering what's on the amateur radio workbench. That's distinct from the equipment that you run in the background that you see here. It's certainly not the average ham shack here. But what we find on the workbench where we have to repair things, build projects, that's the amateur. That's what makes amateur radio, because you may not be aware of this, but you as an amateur radio operator own a class of license that allows you to use any form of transmitter that you put together yourself. You don't need FCC certification for your transmitters. All of your equipment does because it's commercial, but as an amateur, no. You get to make your own transmitters. Of course, you have to conform to the FCC rules, regulations, and laws. They trust you to do that because you took a test. Okay, we'll skip all the legalities and we'll cut straight to the chase, and that's what you would find on my bench, and I'll tell you what you should have for your bench. So I have to shift gears here. Need to. Okay, here we have a Simpson 260. This is a classic voltmeter from my days in the Navy, and certainly is rugged to beat the band. It contains a lot of function in it. You'll notice that the switch there is grouped into current, voltage, and ohms. And I believe this particular meter has a mirrored scale, so that's one of the more precision meters. Mirror scales typically give you an accuracy of about, good ones, 1% of full scale. So if you're reading on a 100-volt scale, you could be assured that anything that you read using the mirror correctly would yield you a measurement that was within 1 volt. 1% of full scale. I have to adjust myself to the screen here. So, moving on. Let's see. And by the way, this is not going to be in any particular order. The Tektronix 465 oscilloscope. Now, this is in a class of oscilloscopes that are rated at 100 megahertz. DC to 100 megahertz signals. It will present to you faithfully within about, sometimes as great as little as 3%. Let's say 5%, at least, easily 5%. You can get these down to about 3%, but that's really stretching things. And I'm sure that no amateur has a 465 that has been calibrated in the last 6 months. And these guys, they take a world of effort to calibrate, believe me. I've done it. I've done it on, I don't know, easily hundreds of these. And the bigger ones with tubes in them, like the one that's over the, you can't see that. Over here, behind this graphic, it's a 567. It's going to be on the slides here, so maybe I should just move on. Yes, the 547 from Tektronix. This is This is a workhorse. This too is well, it depends on the plug-in, but it's 100 megahertz. Well, let's see. I haven't checked these specs in a long time. Now, and it is dependent upon the plug-in that you see at the lower left. This is a great oscilloscope, and it's full of tubes, certainly. The time to calibrate it is longer than the other, and consequently is probably going to be about a 10% instrument if it doesn't have a current valid calibration sticker on it. I've calibrated a lot of these too, and they're spec'd at about the bench time that's projected for a good bench tech is about 24 hours. A good Caltech, such as myself, I can do this in about 6 hours, so about four times faster. There's a lot of interactions going on in this thing, and there's a lot of things to check. However, if you have one of these, it's a great addition to your shack. Now you'll notice that it has 2 time bases and it has 2 vertical channels. So if you're looking for a scope that's more modern than this, or even the other one that I showed you, the 465, you need to look at their specifications and of those replacements that you're considering, and at least meet the specs of this one right here. In other words, dual vertical, dual time base. It's going to have some robust triggering circuitry in it as well, so that so you can get very stable readings. But let's move on. Yes. This is the URM-25D. This is okay, we're going to slip into military gear, which is, the military gear works rock hard, rock solid, faithful, gives you exactly what you expect and more. Stable, powerful. Now the signals that come out of this signal generator is, I believe, 10 kilohertz to 50 megahertz. And it's accomplished by a big band switch in the left center. The meter reveals how much power that you're applying to a load that you would find applied to one of the bottom right BNC connectors. That would be at least 1 milliwatt, if not 12 dB above 1 milliwatt. So 0 dBm or 12 dBm plus 12 dBm. It's a lot of power. And I'm not sure if that plus 12 is available from this, but other generators that I'm going to show you, that will be available. So moving on, the URM-120. I believe this is a 120D. Now this is a bulletproof form of measuring voltage standing wave ratio. In that, if you notice at the top, there's this cylinder that's sitting in the top of this meter. That, let's see if I can point it out. It's, okay, right under my finger here. I wish I could reach into this graphic. Your input is on the left. You can see it at the lower left corner of this machine. And similarly, on the other side is the output. So this is what's called an inline watt meter. And that means that you can place it anywhere that you want as long as you have cabling that provides you with the jacks to sufficiently insert between that connection. And when you twist that this knob, the big one, not the little one. The little one is the range. The big one is direction. So this way or this way? Well, rather than having you take this rig, uncouple it, and swap it around, couple it back, well, you just turn the, it's a cylinder that sits down in the well of this meter, and it has a coupling loop that aligns with the line that runs through from side to side. So it's a pickup coil that's feeding the meter to indicate a power in one direction. The geometries are very simple, but are maintained faithfully through the very large size of the components. It makes it very hard for this to be messed up, and short of just breaking the meter itself. It's very, very robust. I've calibrated a lot of these, and this is much better than the Bird meters that you find, and I've calibrated a lot of those too. So you can trust them, but this one is better, much better. And given this that insert there, the cylinder, that's representative of different frequency bands and different wattage expectations. Typically these are, well, what you're interested in is 100 watts, and there's plugs galore available at that range. But we can get up to a kilowatt, and we can get down to 10 watts. And that makes this a very, very, very flexible, and the frequency ranges too, very up to the gigahertz. So this is a very flexible unit, and this is what would be the macro Bird watt meter. So, but let's move on. I've gushed on. I'll show you more power measurement tools here soon. Here's something that works both as a dummy load and as an attenuator. This is a 40 dB attenuator. That's why you see two connectors at either end of it. And you may note by the rather large solid fins on this block of steel that it's built for power, and this is 150 watts. 150 watts can be applied to this key down, leave the key, just solder the key. This will take it, provided you have enough air circulation. So we'll get into that when I speak about the 50 ohm load. This is one. Buy it commercially. It's made by Weinshle, and it's a type N coaxial. They make smaller ones, they make bigger ones, but this is suited to our purposes, certainly. You don't need the other connection as oh goodness, as a signal reducer, as an attenuator. If you put 100 watts in, you'd get 10 milliwatts, 100 milliwatts out. What's that useful for? Well, that's up to you, but you don't have to use it that way. Here is one that's just a single connection, and it's a Weinshle 50 ohm dummy load. You'll notice that it's a heavy-duty construction with fins to help dissipate the heat. And that can be generous at 50 watts. So care must be considered in efficient airflow. But I'm offering this to you as rock. Okay, everything that I'm showing you here is guaranteed 50 ohms and nothing else for an entire frequency range from DC to 1 gigahertz. You're not going to find that from many dummy load manufacturers, except very expensive. These, I think, well, I'll teach you how to make your own 50 ohm dummy load for power yourself to the same specs, DC to 1 gig and possibly higher. But that'll come later. And now we're going to just move on. The AN-URQ-10. The URQ-10 is a frequency standard. Now, the other things you might see, well, I've had all these on my workbench. You may not need this. This is a frequency standard that's used to source, well, as its name's implied, a standard of frequency that you would use throughout your shack. Some equipment is suited to accepting, and if you look at the bottom of the bottom connectors here, we have a 100 kilohertz, 1 megahertz, and a 5 megahertz frequency emerging from this. That is, when it's calibrated, is accurate to 1 part in 10 to the 10th. Now think about that. That's in the ham radio world, 0.005% is 0.005% is what the FCC expects of you. That's 5 parts per million. This is, well, let's see, 0.1 part per billion. So you may not need this much accuracy, but if you yearn for accuracy, this is the instrument. Probably cost you several $100. But there are other things that I'm going to introduce to you here that will be on your bench, or should be on your bench, that might profit by this particular instrument. So let's move on. Now this is one that you're not likely to have on your bench. This is for advanced users only. This is the General Radio 916A. It is it's a bridge for measuring the reactance resistance, the impedance, of an element that is connected to the face of this instrument. They don't want to dilly-dally around with stray leads introducing, upsetting the balance. So you have to have something that connects smack dab right. If you look at the left knob here, you'll notice that it covers a circular portion of the faceplate that is kind of light gray in contrast to the dark gray of the case. And it has a silver middle. Looks like a circle, possibly a hex. It is a hex. That is a threaded input, and you connect what you're measuring to that point. It measures the impedance of that point in relation to the case of this equipment. Now, that is significant at RF, where you want to reduce all the variables. And it makes this a little difficult to use if you're not used to thinking in terms of stray reactant, stray capacitance, stray inductance, and such things. The 50 ohm load that you're going to build is part and parcel to these issues as well, if you're thinking about operating above, outside of the HF band. If you want to apply your 50 ohm load to, say, 2 meters or 440 or higher, this is a bridge that you won't buy anywhere without spending a lot of money, $10,000 to $20,000. I can't imagine that's what it cost when it was for this instrument was easily worth any tech's salary for a year. this individual instrument. You can buy it on eBay for $600 perhaps, but you're going to have to have a need for it, and we're not going to talk about that right now. Here's a simpler scope. It's a Heathkit 012. This is one of my first scopes. Is a 1 megahertz scope. So its frequency before it starts to fail is about DC to 1 megahertz. Getting above there, this system just doesn't have that capacity unless you connect to its deflection plates, and there are connections in the back that make that available to you. And in that regards, yeah, this could be a 100 megahertz scope by that virtue alone, but you're going to need a microscope to see how the vertical deflection, because the amplifiers aren't going to be, or you'll have to provide your own amplifiers. Most signals don't really allow connection to the deflection plates with any great, let's say, ease. But it's still a very good scope. I used it for years. And you connect it to the IF chain, it gives you a perfect environment to work without getting into the complexities of the front end of any rig, receiver basically, or transceiver. Yes, this is the Hewlett-Packard HP 200CD. This is the working horse of audio oscillators that you want some precision. This is Hewlett-Packard's very, very first design for industry in the 1930s. Of course, this is a much more modern construction than that back in the 1930s, but it contains all the same circuitry, and its remarkable feat was providing a fairly constant signal level across all frequencies, and that is not simple to do, folks. That is not something that's simple. And they achieved that by using the negative resistance of a light bulb in the oscillator circuit, such that it provided an automatic leveling to the signal, giving us this constant volume or constant peak voltage across all the frequencies that this is. And speaking of that, this is from 5 hertz to 600 kilohertz. 5 hertz. This thing can really thump. It's a great audio source. It's rock solid. It's been with us for years. Here we have a power meter, and one that's probably an unusual one, in that if you look down at the bottom right of the graphic here, you'll see a rather complex looking, well, the technical term for it in the Navy was dumaflachi. Yes, this is a power sensor head. And what makes a power sensor head? Well, for this particular meter that's reading power that's applied to this sensor head, there's a number of different technologies available to how the power is dissipated, so to speak. You can do that using a crystal rectifier, a diode, measure the voltage, smooth it out, put it across a known load, extrapolate that to the power, so on and so forth. Or something that's rather more direct is a barretter, where you're measuring the heat of the power that's being lost. Let's see. You also have what's a Wollaston wire type of detector. That's the power is being applied to a wire that warms up, but is already warm, and the shift is measured by other circuitry, and that's why we have this complex box sitting here. So there's a number of different technologies that are available to the scientists and the deep techs, say like in the National Bureau of Standards or in, let's say, defense technologies that need accurate measurements of power, and there are some forms of measurement that are more accurate given the frequency that you're using and the levels of power that are being applied. And this is quite often paired with power-reducing elements so that the range can be extended, and that's through the use of directional couplers, and we'll come across those. These things should be on your... This perhaps will not be on your bench. You'll probably find something that's lower, more constrained to your usage. And that'll probably be cheaper, much cheaper. But if you're striking out for precision, this should be on your bench. This is the Cadillac of power measurement. This is the Hewlett-Packard 434A. This is primary standards laboratory grade stuff back when I was serving. This is the absolute standard for measuring power because it's doing it by measuring two different heat sources. One, your power being applied to a resistor, it's measuring that temperature. And two, its own load that's creating its own temperature that it's also measuring, and it knows to compare to your applied power. This is all done inside this box here. It's a big box. It has some special needs, believe me. One of them is this circulates a special oil past two heat loads to figure out the caloric difference. This is a calorimeter. This measures calories, the ultimate form of power. I don't expect any of you will have something like this, but if you seek to measure power to ultra precise with given all the this is ultra precision, you're not going to get much better. This is high quality. It's still, I think this would run you about $600, but people would back away from making any claims on what they were selling you, believe me. So don't approach this without some guidance. Someone with experience, yes. Here's the Hewlett-Packard 608. This is a 608. This is a beautiful, it starts in the HF, but it goes up to the VHF and not UHF. It gets up to about 480 megahertz. And like all the other generators that I'm speaking of here, this is rock solid output. This definitely has a plus 12 dBm across all frequencies and sometimes a lot more. This sucker really has power galore. The frequencies are rock solid. The virtue of this is in the lower right dial that varies the output of that source. Now, like I said, plus 12 dBm is monumental as far as a signal, but it's not very useful. You need to attenuate that. You can grab all that raw signal if you want, but this lower right knob is an attenuator that's called a cutoff waveguide attenuator, which means that it has a loop that's moving through a can that's separated from another loop, and the difference between those two, that separation distance is very, very linear in the log domain. And this knob has a log domain calibration markings that are linear to dB. So each increment turn is maybe 2 dB, 120 dB, that easy. And it is, believe me, it is rock solid. It's quiet too. This source is, it's clean. It's very clean. Now this too you can probably get in other sources. Certainly everything's been digitized. You might want to price compare on this. It's a rugged beast. It's standing on its back in this view. So this is looking down on the floor to its face. And that's a very, very useful arrangement. Unless you've got a very deep bench, because this sucker is deep, 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 a good 18 plus inches deep. But something like this should be on your bench. But not this. This is a Hewlett-Packard 805 slotted line. It's used for measuring, guess what? Well, you're probably not going to measure, but VSWR, Visor. And you do that by moving the carriage on the top of this, which has a probe that goes down to the center conductor that passes between the two connectors at either end. Just a moment. I've got a telephone call coming in here. Oh, goodness. So, let's see. So, the slotted line, that's not particularly going to be useful to many hams. Unless you're looking to do precision, again, measurements of power. It's an absolute necessity at that point, because you have to reduce all the standing waves for one. That ain't pretty. I've done that, and I've done a lot of that too. So, but it's certainly not something that is demanded of you. Here we have a frequency counter. Now, this particular frequency counter, the Hewlett-Packard 5245, I've calibrated a lot of these. These have their own internal frequency standard, or they will accept an external, which will, depending upon the external frequency standard, will increase or certainly decrease their accuracy. The URQM10 will certainly increase the accuracy of this instrument right here by several orders of magnitude easily. However, if you have simply this or one like it from the marketplace that exists now with it's a watch, and you can do it on your Android measure frequency if it's audio. However, this is more robust in the sense that it covers a lot of different frequencies by virtue of that right. You'll notice on the right there's a little module with a knob, and it's for frequency conversions between 3 and 12 gigahertz. That's reaching high. It'll do lower, certainly. It'll do DC to 1 megahertz, certainly, yes, and higher, just in its native form. But this has other functionality in that it also measures time. Have you thought about that? Mostly interval kind of time is what most engineering is concerned about. This has, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 position switch here for measuring time. 1, 2, 3, 4, 5, 6. This is a very flexible instrument. Its precision and its accuracy are phenomenal. And as I said, I've calibrated quite a few of these. They're rock solid. So moving on. Directional couplers. This is for the people who want to do serious work with measuring power. In this case, the power would be going in on the left and coming out on the right. The left you see is a male connector. That's to be connected directly to the source. The right side is to the load, and the load is generally has its own male connector. The two connectors that you see face on are outputs, and each is characterized by a frequency calibration chart associated with that connector. And you'll notice that this particular device is designed to work between 1 and 4 gigahertz. When you get higher in frequency, the device gets smaller. But this is strictly when you get into directional couplers, you're getting into physical dimensions and their wavelength, and the wavelength of the signals that you're interested in. These kind of devices work on octaves, so 1, 2, 4, 4, 8, 16, or just one octave, 4 to 8 gigahertz, 8 to 16 gigahertz. Those kinds of metrics are applied to these devices through these relationships of wavelength. And as these are physical devices, they have a certain limitation in the distance apart that these two connectors are to exhibit this kind of directional coupling. I won't go into the discussion of how the coupler works, but this is by Narda. Narda and Weinshle, premier component makers in this regard, and you'll find this on the surplus market, probably steeply discounted to the commercial equivalents. And believe me, once they're built, they stay there unless you just fry them, and that'll be evident in their operation. So they either work or they don't. I can't imagine how they don't. These are bulletproof. My goniometer. This is included. You won't have it on your bench. You don't need it. But unless you get into doing the adcock array, which I describe in antennas. But this is what a goniometer looks like. It's a variable phase transformer with two inputs, which it mixes to produce the phase output from the coil that is wound on the center rotating core. So this is included for historical purposes. Like I say, I don't expect you to have it. I had one. This was the first thing I bought, 1965, at an amateur radio auction that I went to. Let's see, I must have been all of 15 at the time. 16. I worked in radio and television repair shops. There's a story to that too, but not now. Where one of the owners, the shop owners, was an amateur radio operator, and he had a kilowatt rig that every time he keyed down, the house lights would. He put a heavy load on the house's electrical system, to say the least. That's when I bought this, was when we went to the ham auction there in Colorado Springs, and that was a rowdy affair. But moving on. We're back to the Simpsons 260. So I guess let's see if I have anything else that no. Yeah, there we go. The full slate. Yep, there we go. So, time to return to the shack alone. And I hope that that gives you some insight as to what's been on my bench, what instruments that I've used, that I've worked on, I've repaired, I've calibrated, I've overhauled, all of this stuff, and a lot more. Everything behind me that you see, yes, I've worked on all of that stuff. So, but what you need on your bench is a good source of meters and indicators, and certainly, let's see, I have a lot of test leads, whoop, right there, hanging on the wall. Yeah. Okay, so it's time to wrap it up and say, I hope I brought some valuable insights. Ask questions if you have any. Look forward to you in future videos. 73s. Thank you.